Good afternoon, everybody. Can everyone online hear okay?
Yeah.
You hear me? Oh, wonderful. Welcome, everybody, to Client Earth. Please, there's some food next door, so feel free to take some and to keep eating. The idea is to be relaxed and to enjoy lunch. It's very exciting to have you here at Client Earth's office. My name is Adam. Adam Weiss, I'm head of Ocean here at Client Earth, and we've put on this workshop today with our friends and partners at Hourfish. I'm pointing to Beck from Hourfish. It's very exciting for me to see you all here because I joined Client Earth a week before the first lockdown began, so I'm not used to inviting to being in this office at all, and certainly with other people, so it's very nice to have you all here. We're here today to talk about the decarbonization of the fisheries sector. The most recent IPCC report made it very, very clear that we've got a rapidly narrowing window of opportunity to deal with the climate crisis and to take direct and comprehensive action. We've already seen an increase in temperatures of 1.1 degrees Celsius, and we're already seeing the extraordinary natural disasters that result from that. If we're going to drastically cut emissions by 2030, every sector is going to need to play its part, and that includes the fisheries sector. It's also been universally acknowledged by scientists and by economists that we need to end fossil fuel subsidies. Here in Europe, the war just over our border in Ukraine has put into sharp relief just how quickly we need to wean ourselves off of fossil fuels. Fishing in particular is a very intensive greenhouse gas emitting activity. The global fishing industry's emissions were estimated in 2016 to be 207 million tons. And one of the issues is that the fishing industry's emissions are excluded from global assessments of greenhouse gas emissions. So we've really got to start tackling decarbonization of the fisheries sector. This is also in line with the European Green Deal. So we're all pushing in the same direction. We've got a particular opportunity to decarbonize the fisheries sector through the revision of the Energy Taxation Directive. What we'd like to see at Client Earth, at Hourfish, at many of us working on fisheries, is seeing money getting funneled into cleaner technologies instead of getting used to subsidize the same old polluting technologies that power overfishing and climate change. Maybe I'll just share with you a couple of the objectives that we have for today's session and then hand it over to our first speakers. We really want to present the latest research and progress on decarbonizing fishing fleets and maritime vessels, seeing how we can take inspiration from what's being done with shipping, identify research gaps for realizing the decarbonization of the EU fleet, and identifying areas for priority investment for decarbonization. So I'd like to hand it over for our first case study to, and I think we're already seeing, yes, wonderful, to Cecilia Gabrielli, who is a research scientist at SINTEF, who's going to give us a brief overview of the research in the area and case studies of current work with fisheries, including the potential for ammonia. Cecilia, I hand it over to you.
Thank you very much. You can hear me and you see my screen.
Yes.
Yes, excellent. Thank you so much for inviting me. As you said, I work as a research scientist and project manager at SINTEF Energy Research in Norway. And SINTEF is one of Europe's largest independent research institutes. So the figure here, it illustrates the approach that we try to have in our projects related to decarbonization of the maritime sector. And it also forms kind of the outline of my presentation today, where I will give some examples from different projects. And starting from the bottom with energy or emission analysis, which we believe is crucial for taking the correct measures towards decarbonization. So in 2017, we made an extensive study on analyzing the GHG emissions from the Norwegian seafood sector. both related to various species and related to various fishing vessel types. I will not go into the results here because our main experience from such studies is that there is a critical lack of operational data from ships in general, but especially from fishing vessels, which makes it kind of difficult to draw solid conclusions. The data in such studies are often based on rough estimations of annual fuel consumption, often based on engine power installed, actually. So we think there is a strong need for onboard continuous measurements. For example, it's very important to disaggregate between the fuel consumption for different usages on board, even though propulsion is the largest. Some fishing vessels has a large fuel demand for refrigeration and other process equipments. So in one of our research projects named Coolfish, we have made some research cruises where we collect such detailed data. For example, detailed measurements of the fuel consumptions, temperature measurements in the refrigerated seawater tanks, and etc. And this, together with data on catch, weather, speed, etc., and also observations of the operations on board, we believe form a good basis for reducing the energy demand. So by discussing with the crew and doing detailed data analysis, we can identify both simple everyday actions on existing ships, but also, of course, give valuable input when the next ship is to be built. And that takes us to the next 3 pillars. And here it becomes a bit more complicated because these 3 are kind of dependent on each other. So here, to avoid sub-optimization, it's very important to take a system thinking approach and iteration. Just one example, the new propulsion systems and alternative fuels that are available or will be available, they offer various opportunities for waste energy recovery. For example, if you use a cryogenic fuel like liquefied natural gas or biogas or hydrogen, it enables coal recovery to support the refrigeration system and reduce the energy demand there. If you use combustion engines or high temperature fuel cells, it enables heat recovery for power production or for refrigeration or for heating demands. And that is actually kind of independent of which fuel you use. But on the other hand, if you use low temperature fuel cells and batteries, this has very limited heat recovery options. So the choice of propulsion system must be made with an integrated system approach. Looking a bit on the top pillar, so what's actually available and used today related to fishing vessels is hybrid propulsion, either based on diesel engines and batteries, but to reduce the carbon emissions a bit at least, you can use LNG as fuel. And the statistics from DNV shows that, or you see here, the number of vessels in operation today with these solutions and under construction. And as you can see, among the total number of ships using these solutions, there are very few fishing vessels. And actually, many of them are from Norway. Yeah, but what about tomorrow? Or maybe more, what about 2030 or 2050? Well, LNG and diesel can be replaced by biofuels and e-fuels. But today I will focus a bit on ammonia, and also hydrogen will be mentioned, because we believe that they will have an important role in the future, both in combustion engines or in fuel cells. There is a large research program in Norway called the Green Shipping Program, which is led by DNV. And there will be a pilot study of a fishing vessel using ammonia. And of course, there are very many obstacles with using both ammonia and hydrogen, as you probably are very well aware of. For example, there is a lack of bunkering infrastructure, there are safety issues, and the technology for using these fuels on board is still immature. And also, as important, a value chain must be established to ensure that ammonia and hydrogen are produced in a carbon neutral way. But we also see some benefits with ammonia related to hydrogen. It takes much less space on board. and it is kind of a more known substance. It's already used in refrigeration systems, for example, on board fishing vessels. And also the LNG bunkering infrastructure that is building up today, it can be used instead for ammonia. So going back to the two pillars below the alternative fuels, this is a fishing vessel that will be delivered in 2023, and it will be the world's third fishing vessel operating on a hybrid propulsion based on LNG and batteries. So it is kind of designed with the best option available today, but it can be replaced with biogas when available at a reasonable cost. So switching from diesel to LNG, you gain about 20% reduction in greenhouse gas emissions. But as you see here, we have stated that it's 40% reduction. And how is that? Well, that is that we have made a lot of energy efficiency and energy recovery measures that adds to the 40%. So and many of these measures are direct or indirect results of some previous research projects that has been made in collaboration between SINTEF, shipping companies and equipment suppliers. And for example, this ship will utilize cold recovery from the LNG system that will reduce the energy needed for refrigeration. And the waste heat from the engines will be used both for produce some extra electric power and to supply heating for any heating demands on board. So this is of course a great step towards decarbonization, but the main question here is how to realize the introduction of carbon neutral fuel. And here we believe that the kind of success factors is to develop the infrastructure for production and distribution together with the end users and the prototypes being tested. So we need collaboration projects with partners from the whole value chain. And in Norway, we have something that is called the Green Platform Initiative, in which the Norwegian government support this kind of projects to stimulate bigger and more rapid investments in the green sustainable solutions. And one example of such a project is the, one example of such a project is the ammonia fuel bunkering network, which consists of an industry project led by an industry, Sane Fuel Solutions, and a research project led by us at SINTEF. So this project consists of project partners from the whole value chain, and the main goal is to realize an ammonia fuel value chain for the first ammonia fueled ships. So it includes designing and developing and building a flexible bunkering hub at a certain location that will be chosen based on aspects such as distribution and end use, and of course safety. And the research project, it will support the industry project by developing and disseminate knowledge to kind of facilitate the use of ammonia as a zero carbon maritime fuel, but in a more longer perspective. So here we will contribute to the technology development of the end use on board in both combustion engines and fuel cells. And we will also develop better methods to make value chain analysis of ammonia as a cost-efficient and safe zero carbon maritime fuel. So even if my presentation should not focus on hydrogen, I would just like to mention that we have another such green platform project, which is directly related to fishing vessels. So it also includes the whole value chain. So from local production of hydrogen and end use by fishing vessels having a hydrogen electric propulsion system. So thank you.
Thank you so much, Cecilia. That was a really fascinating look at the technologies, and I think also a very sobering point at the beginning about the fact that we actually lack the data about the emissions that are coming from vessels, which is extremely important if we're going to make change in this area. I am going to invite next someone who is in the room, Michael Arts.
Good day, everybody. Thanks, Rebecca, for inviting me today. Thanks, Client Earth, for hosting us here. My name is Michael Arts. I'm General Manager Market Innovation from Wärtsilä, and I have a presentation on decarbonization of the marine and energy sector, but focusing clearly on fishing. Couple of words on Wärtsilä. We are active in two main sectors. One is the energy sector, the other is the marine sector. In the energy sector, we are supplying basically flexible energy production systems. This is a combination of engine-based power plants associated with battery hybrid technology and the whole control systems that go around that, which is very important with the upcoming renewable energy. The other one is the marine sector. And in the marine sector, we are manufacturing systems that produce power on board, distribute power on board until the propulsion system. So basically everything from bridge to propeller is what we do. And that is combined with exhaust gas cleaning solutions, fuel gas supply solutions. You will find that sustainability is kind of at the core of the activities of what we do. So I'm quite confident to say that every system that we produce has a sustainability angle and has been driven by sustainability. And I think for all of our customers, whether it's the marine or whether it's the energy business, we are a life cycle partner. So we are with them from the start of the project completely until the end of the asset. So in shipping, we are literally talking about 35, 40 years of lifespan easily. Just diving straight into the matter of how to decarbonize shipping and specifically also fishing, we see that there are three main elements. You kind of saw also similarities with the presentation from SINTEF, which is not a surprise as we use technology as the basis of writing our and defining our roadmap. The first one is focusing on efficiency. This is about most efficient engines, most efficient propulsion solutions, energy saving devices, multiple speed gearboxes. How do I make the ship as a system function as efficient as possible? The second step, what we see is electrification. Everything that I do by using direct electricity instead of combusting any type of fuel is more or less a gain. And some logic items such as shore power connection, making use of shore power electricity when the ship is in port is of course a quick win. But we clearly also see that shaft generator systems, having the main engine not only propel the ship, but also produce the electricity instead of a separate genset is a good example. And we see also that hybrid battery technology, more or less the same as what you see in modern day cars, also supporting the stable energy production on board of fishing vessels as a good method to decarbonize and reduce emissions. The third building block, if we look at the first two, we have reduced the amount of energy that the ship needs, and we have produced the amount of energy in the most efficient way, but we still need to decarbonize further if we want to meet, let's say, IMO goals. Fishing is not regulated by IMO or currently EU decarbonization goals, but let's say we target for the same objectives, then we will need green fuels that have low or zero carbon, and they can be from biosources, they can be e-fuels, synthetic fuels. So I've listed a couple of examples here: methanol, ammonia, hydrogen, but LNG, and there certainly will other examples also coming to the daylight. Next to that, full electrification may also be an interesting route, but this, in our view, is limited to ships that have a relatively short endurance. If you speak about ocean-going trawlers that need to cross large distances, then full electrification, in our view, is out of limits. And of course, optimization in vessel routing, fish finding, most efficient speed going from A to B. Those are kind of logic starting points altogether, as that is already, let's say, common practice today. I've now 2 slides with some examples of what modern day fishing vessels are capable of doing, just to explain a little bit more on what technology are we now speaking about. The example that you see here is a project that we are doing for a shipping company, Harthouse. Our supply is basically the system on the right. You see here the internal combustion engine on the right. Let me step a little bit here. There is the internal combustion engine. There is a multi-speed gearbox with a shaft generator. The shaft generator is producing the electricity. There is a highly optimized propulsion system connected to that. And the ship is also using battery hybrid technology. The battery hybrid technology is not so much placing a battery on board and plugging it in, but this is very much about making sure that the system as a whole is functioning. What you should see is that a ship like this trawling in the big oceans is subject to very much load fluctuations, operating in waves, systems on board being switched on, being switched off, and this all is causing a load variation on the internal combustion engine. And what this hybrid technology is doing is that it is stabilizing the load, and that allows for the ship designer to select an engine and to design a ship that is using it literally at the most efficient operating point. So our message here is that the individual building blocks need to be, let's say, as efficient as technology can be achieved today, but also the integration of those systems. Harmonizing everything is very important to get the gains from all these technology possibilities. Here is another example. This is not a fishing vessel, but this is actually a krill transporting vessel. So still very much active in the fishing domain. Here we are also speaking about a full, let's say, propulsion package supplied by Wärtsilä. Also good to kind of state that the engine on this project and on the previous project is actually a world record holder in terms of efficiency. It's recognized as the most efficient internal combustion engine, which is, in our view, kind of a starting point, an obvious starting point, as let's say, reducing carbon emissions starts with gaining the highest efficiency from the combustion systems. And then also again here associated with hybrid technology, shaft generator. Here there is an echo control system. That's also a smart control system that senses in what kind of wave operations is the ship operating, and thereby also optimizing the engine control accordingly. If we speak about the last building block, low carbon fuels or zero carbon fuels, in our view, that's an essential part to make full decarbonization possible in shipping, and certainly also in fishing. If we look at today's world, then we are mainly a fossil-based fuel. It's largely heavy fuel oil, marine diesel oil, and LNG. All are fossil-based fuels, and that's by far the majority of the fuel being used. But we are moving to a world where we see more and more biofuels becoming available on the market. When it comes to biofuels, you have first generation, second generation, third generation biofuels. Obviously, the biofuels need to have a sustainable production footprint, so a sustainable feedstock. But when that is the case, then biofuels can be an effective way to decarbonize the fishing emissions. If you look at bio LNG, for example, that can be easily mixed with fossil-based LNG. So that's a type of fuel that can be blended in very easily into the shipping domain. However, in the current market, we see no fishing vessels using LNG as a fuel. So current fishing is still very much based on using liquid fuels. So their biodiesels could be an interesting method to decarbonize these vessels. However, biodiesels we know are extremely expensive, so that will definitely have a large OPEX effect on the fishing vessels. If we move further towards 2030, we will see that we will also start to see blue fuels coming onto the market, whether that is methanol, whether that is ammonia, whether that is hydrogen. With blue fuels, we mean that LNG is used to extract hydrogen, and that the carbon is captured and stored in subsea wells. So, for example, we see that the first projects implementing that kind of technology are started up today, and this is something that can be scaled up. So that could be a source of blue hydrogen, and then making that blue hydrogen to produce another fuel, either use it as a fuel directly, or produce methanol with it, or produce ammonia with that. And when we move further towards 2040, 2050, then we will hopefully see that there is abundant renewable electricity available to make directly hydrogen, and from this hydrogen create another building block, ammonia, methanol, or even synthetic methane, for example. Also good to point out is that the fishing segment in the maritime industry is a very small player in terms of fuel consumption. So the fishing segment will not determine what type of fuel will be available where. So the fishing segment kind of needs to follow the footsteps of what other industry giants are doing. And you see that Maersk and MSC and large shipping companies are now taking the first steps. Maersk is moving towards methanol. CMA-CGM is moving towards LNG, blending in bio-LNG. So those companies will determine what the fuel infrastructure will look like. And the fishing segment needs to follow these footsteps when they make sense, specifically for the fishing segment. Then I come to my final slide. It's clear that on the policy and regulation that there is a lot of development currently ongoing in the maritime industry. Fishing is currently exempted from EEDI, EEXI targets. There is no carbon intensity indicator for the fishing vessels, which is in development for the other shipping segments. So this is certainly something that has a big effect. We see that the access to capital, so investors lending money, have much more awareness of where their money is going, and is that a green profile, or is that having a not green profile? Cost of carbon, we see that the EU with the Fit for 55 is working on taxation of carbon emissions. It recently has taken kind of a setback in terms of implementation, but the expectation is that sooner or later it will come, and the current price of carbon is, if I remember correct, above 85 euros per ton. So if that will be implemented, that will be a big OPEX item for any company working in the maritime domain. And we also see that consumers as a whole, so basically us, people who kind of eat the fish, are more and more aware of the production footprint of what they consume. So our focus is on carbon neutral and zero carbon fuels. This is where we make sure that our portfolio is capable to work with. We clearly see that when it comes to battery systems, hybrid solutions, and energy saving devices, a lot of development, a lot of technology is currently possible, which is finding its way into the modern day fishing vessels. And we will probably see that more and more. And there is clearly a focus on fuel efficiency and, of course, the use of data to make sure that the ships are optimized in the way they are used. My message for you today is, as a key takeaway, is that low and zero carbon fuels sooner or later will be vital for the shipping industry, and specifically also the fishing industry, to achieve decarbonization goals. Fishing will not determine the fuel infrastructure, so they will have to follow the footsteps of other industry players that are determining that. The ship technology itself is becoming more complex. If you look at a modern day fishing vessel, it's already an extremely complex vessel which is chock full of systems and equipment which all have a function and a place on board of that vessel. So integration of all those various systems will be key to harvest the gains that these systems can bring. Space is limited on board of a fishing vessel, so the zero or low carbon fuels, ammonia, hydrogen, methanol, take up much more space than the current heavy fuel oil or marine gas oil. So making a ship twice as large because you need to bunker hydrogen, we need to think about what is the sustainability angle in that, and is there an economic return for a fishing company to operate such a vessel. So space is extremely limited, and this is more or less for the policymakers. Clear and harmonized regulations will be essential to decarbonize fishing, and we are here to help you with that and to answer all your questions. Thank you.
Thank you so much, Michael, and particularly for those the 5 takeaway points at the end.
Good.
I'm going to quickly try to rejig the technology so we can get our next speaker online. I'm going to stop sharing on here. No, it's unplugged already. Actually, what we did was but I think I need to stop the sharing. Yes. And our next speaker is Cristina Alexandre Munoz, who's the CEO and co-founder of Bound for Blue. And I think that we see her already on the screen. Welcome, Cristina.
Hello, good morning. Let me share my screen. Okay, can you see it?
Yes, we see it perfectly. Please go ahead.
So today I'm going to talk about a fuel which is renewable, truly renewable, which is used at point. So you don't need infrastructure to supply it, and neither infrastructure you don't need to store it on board a ship, and something which is available and free, and so you're not subject to price volatility. And this is wind. So we're talking about ammonia and hydrogen, but we're forgetting one of the resources which was used centuries ago and which today can also be applied. And this is possible thanks to all the advancements that has happened throughout the last years. So this is what we're doing at Bound for Blue. We have designed a suction sail named e-sail to reduce the fuel consumption and pollutant emissions of ships. So our technology can be installed in both existing and new built ships. And we are focusing on bulkers, tankers, and so on, but it can also be applied on the fishing fleet. And that's the main purpose today, to show that the fishing vessels can also take profit of this type of technology. So Bound for Blue is a climate tech startup, which was founded in 2015. And since today, we have deployed our technology on 2 ships, and we're generating first savings. And later on, I will explain you how. So this is going back to basics, but not that so basic. So our technology is more similar to an airplane wing. So it's based on rigid materials. It works fully autonomously, so you do not require crew to operate it. And it can be also folded thanks to a tilting mechanism. So when you need the wind, you just push the button and it starts working, the technology. In case you don't need it, or there are some circumstances where you want the sail not to be operating, then you push the button and it stops working. So it's a safe sail technology. Here you can see the first unit, a 12-meter high sail. Laterwards, I will explain you how it works. This is the main structure, so you can see it here on the top. There's the fan. You can see the gray part is the suction area, and here the blue part in the left side, it's the flap, and I'll explain you a little bit more now. So how does it work? Just like an airplane, but in this case, when the suction is off, it doesn't generate any force. But when you suction, which means that you are activating the fan that's on the top, you adhere again the airflow, so it attaches, and you generate lift and obviously drag. And this lift and drag is used to propel the ship. Everything that is given by the sail does not have to be given by the engine, and that's where reduce the fuel consumption and the pollutant emissions. We obviously have a lateral force, but it's minimum. So what we do is orientate towards the wind, so we maximize the lift coefficient, minimizing drag. You obviously, as soon as you keep increasing the angle of attack, the lift coefficient keeps increasing, but there's obviously a limit. So if there's an excess of angle of attack, then the airflow obviously detects as any other lifting device. So with respect to other technologies like conventional sails, or even if we are focusing on rigid sails, we're offering lift coefficients of between 6 and 7, so we're around 6.5, and normal rigid wing sails are around 1.2, 1.5. So that means we are delivering the same amount of thrust, having around 4 times less surface. So that it's really useful for the fishing fleet, because we're able to have devices with less weight and obviously less effect on stability. So I was talking about these rigid sails, but basically the e-sail combines the advantages of regular rigid sails and obviously flattener rotors. So we're having these high lift coefficients of around 6.5, but without the rotating need to generate the lift. So we just need the fan, so that is less consumption to move the fan rather than to move the whole technology, which could not be applied on a fishing fleet. And at the same time, we are not having movable parts, just the bearing, the rotating technology, the one at the bottom. So we just have to orientate, but it's not the same. And that is pretty similar to rigid sails. So we're having lower maintenance cost and lower, obviously, capex. Our technology can obviously be used with alternative fuels, and that's very useful because today, like around 14% of the fuel that is in the market is coming from renewable energy. And the problem is that it's around 3 to 10 times more expensive. So if we have limited amounts of really true renewable fuels, by using the wind, we're able to really decarbonize more ships, not only fishing fleets, but overall ships. And as I told before, our technology can be installed in all segments from 1 to 7. We are not targeting, for instance, container ships and so on, because there's no available space. So approximately 80% of the global fleet can benefit, and obviously fishing vessels. If there's a space limitation, then we cannot install our technology, but I mean, that's not the normal case. So we made our first installation. I showed you before the 12-meter sail on this longliner. It was performed in Panama. It was funded by the European Union, and this ship has been traveling with our e-sail around 1 year. We've received data, and the fuel savings are between 5% in worst-case scenarios where wind was not so favorable, and up to 15% in some cases we've reached. And this is with the last design that we performed, which is 30% less efficient than the one we are delivering today. So this is a technology that it's being upgraded, and obviously the efficiency has grown throughout this year. We've learned a lot, we've applied a lot of changes, and this is translated into a better system in terms of thrust delivered. We also performed another installation on a general cargo vessel. This one is a 17-meter high sail. It's the largest suction sail ever built and installed on a vessel. It's also a tiltable system. So here you can see it on the left side, which is something that I mentioned before. This is not to be applied on the fishing segment, rather on bulkers and maybe general cargo. But this one was a specific case to put this type of device of tilting mechanism. Then we're also doing another installation. So this in another general cargo vessel, we're installing 2 units on the back, and this one will not be tiltable. The reinforcement has been done around 2 weeks ago on the Netherlands, and the vessel will will receive for sales by the end of this year. So they're being manufactured right now. We've also signed agreements with Louis Dreyfus, which is another ship owner in the Ro-Ro and ferry segment. And next, our idea is to install our technology on tankers and bulkers. And we are right now in advanced conversations with several ship owners to deploy our technology throughout the next year. So I'm happy to solve your questions, and thank you very much.
Thank you so much, Christina. That was very exciting to hear about the use of wind in a new way. I find that very, very cool. We've got, I know you're available to answer questions, but we're going to do one more presentation and then we'll open up questions for a few minutes, if that's okay with everyone. And our next speaker is George White, who is the Deputy Technical Manager at CMB Tech. George, the floor is yours.
Hello, everyone. Let me just try to share my screen. Let's see. Can you see my screen?
Yes, it's perfect. Yeah.
Excellent. So thank you again for the invitation to speak today. It's exciting to see all the transitions in various sectors of the industry, and it's yeah, exciting to be a part of. As you mentioned, I'm George White. I'm a systems engineer over at CMB.tech, predominantly working on the maritime-based programs. And today I'm just really here to give insight into our current approach to decarbonisation of the maritime sector. So who are CMB Tech? CMB Tech are a clean tech R&D division of the CMB brand, which is looking at low carbon solutions for a variety of industries such as automotive, agricultural, but being a shipping company predominantly, our core focus is the maritime industry. We're a family-owned business founded in 1895 with a head office located in Antwerp, but with a global reach in Tokyo, Hamburg, Hong Kong, to name a few. We are strongly committed to achieving a zero carbon emissions. As mentioned by our CEO, Alexander Savris, we are aiming to do so by 2050 by offsetting all of our carbons and truly running a zero carbon emission shipping fleet. So to give insight to some of our key projects in the low carbon side, we've got a pathway towards zero emission shipping, which involves looking at our smaller vessels, which is here you see the Hydroville, which is a 16 passenger ferry. Up until currently, which we've got out is a Hydrocat CTV, which is currently operating in the North Sea, providing a clean approach to staff maintaining the North Sea wind farms. We also are interested in the infrastructure of our industry. As you can appreciate, hydrogen is a chicken and egg situation at the moment. Without the demand, we cannot have the infrastructure, and without the infrastructure, we cannot have the demand. So we are strongly invested in looking at ways of refueling our own systems, but also other companies and other manufacturers' systems. So we did this by creating the first multimodal refueling station, which allows for refueling of both land-based and sea-going systems simultaneously. With our future developments looking at larger container ships and tugboats, which is currently in build at the moment. And also being a green company, we don't just see one fuel as the potential golden bullet to solve the decarbonisation issues with the shipping industry. We've also strongly invested in ammonia with producing the world's largest, not world's largest, sorry, a large scale production plant for green H2 and ammonia in Namibia. So how do we get our hydrogen systems on board vessels with minimal disruption? At the moment, our core focus is on the dual fuel technology, where we inject hydrogen as a secondary fuel into the air inlet manifold, which allows for the same power output on the system, minimal intrusion to the system. As you can see here, it's just a small ring that goes onto the current existing engine with minimum disruption, and this can allow us to have CO2 savings up in excess of 50%, depending on the load profile and depending on where we're operating on that profile. The current benefit for dual fuel is that If there is ever any issues with your secondary fuel, for example, you run out and you're unable to refuel, you've not lost the full capability of your system. You've still got means to get back to port, get back operating, so there's effectively no downtime. And also, as everyone knows, fuel cells are currently still very, very expensive due to the precious metals and rare materials that go into them. So this is a very cost-effective bridge to allow us to get a low carbon fuel out into the industry. So what projects have we done so far? So firstly, our first pilot project was the Hydroville, which is the first certified passenger shuttle that uses hydrogen. And this system's been operating for 5 years out of the Port of Antwerp, mainly helping our employees in our Antwerp office get around the issues of the Antwerp traffic in the morning by allowing us to cross the river. So it's a good means for us to reduce our own footprint. We then moved on to launching our Hydro Bingo, which was originally commissioned to operate in the Olympic Games in Japan. But as everyone knows, COVID really delayed everything and it was unable to serve its function there. But since it's been launched at the end of last year, it has been operating flawlessly as a passenger ferry in the Japanese coastal waters. And that allows for shuttle of up to 80 passengers. Our most recent vessel that has just launched into the water as of a couple months ago is as I previously mentioned, it's the Hydrocat, which is operating out of the North Sea, allowing crew to transition and maintain the wind farms in a low carbon manner without having a dirty diesel taking these guys out to maintain a clean renewable fuel. And as you can see here in the center, we tried to install our systems. These are our hydrogen cylinders behind the wheelhouse, and we tried to do it with minimum intrusion onto the cruise functionality without causing any implications. And finally, the Hydrotug, which has been operated, which is just launched into the water and is currently going through its outfitting stage and should be operating at the end of this year in the Port of Antwerp. This is our largest system as of yet, which will be running 2 2-megawatt dual fuel engines with up to 400 kilos on board to allow for 10 hours of autonomy on dual fuel in a typical day. But as I touched upon earlier, we're not strictly focused on just shipping itself. We're focused on port equipment and everything that's involved with power generation. So here we have one of our monofuel medium speed B hydro engines that is capable of producing up to 2.7 megawatts of energy for onshore power generation applications, which typically we see as ports to create a real hydrogen hub to allow for quick deployment of our systems. And also a straddle carrier. As mentioned, we are the developer of the world's first multimodal hydrogen fueling station. We believe as a company that you can't expect the infrastructure to come to you without proper investment from yourselves. It's going to be very difficult to make any real gain on the industry. So we went ahead and developed this multimodal refueling station, which allows for refueling of both our Hydroville here and also our hydrogen fuel cell vehicles, but it is also open to the public, allowing for any people that are operating these green systems to refuel. And yes, the Namibia project is the construction of the Africa's first H2 refueling station with a 4-megawatt electrolyzer. We're also aiming to achieve 1 tons of green ammonia in the form of a factory to help us progress with our future projects, which I will come on to later on the larger scale container ships. What we've found, as I previously mentioned, we're not guaranteed to have hydrogen supply at where our systems are developed. It could be we're in a shipyard down in Spain, or we're at a shipyard in our backyard in the Port of Antwerp. we've not always got the availability to test our systems properly prior to shipping them out. So what we did was develop our own mobile hydrogen refueler, which is a 500 bar tube trailer essentially that contains up to 950 kilograms of hydrogen, which allows us to have no issues when trying to perform our harbour acceptance tests and sea trials down at any shipyard within Europe, really giving us an edge on transitioning. So what are our future projects? We are currently looking into major projects to do with the container shipping industry as well as the coaster vessels. So here we have one which is a co-development with Bookmans, which will be operating on dual fuel as well. We're looking into a ammonia bulker, which is open to be delivered at the end of Q3 of next year, as well as a ice class 6,000 TEU vessel, which would run on dual fuel ammonia and diesel. And finally, the chemical tanker, which again will be operating ammonia/diesel. As we touched upon earlier, hydrogen is a very hard fuel to transport and store due to the amount of storage vessels you would need to get enough autonomy. So ammonia can be a real bridge to get around that. And finally, we are looking at a power barge which will be operating monofuel hydrogen, so it'd be 100% green fuel, which will also provide clean energy to vessels, as well as being a means to mobile refuel on the water. Thank you for your time. Sorry that I overrun. And if you have any questions, please feel free.
Thank you so much, George. Really interesting to see how hydrogen is being used. We've got a few minutes now. If anyone has any questions for clarification for any of our speakers before we get into our workshop discussion. Silence. Because we all understand all of the technologies perfectly.
Yeah, perfect.
Is it, someone does have a question online? Oh, yes, Bjorn, go for it.
Thank you. So it's not only technical questions. We can ask any questions now to the speakers, yes?
Go for it. Yeah, absolutely.
Okay, thanks. Yes, very interesting because there are several projects going on also in the parliament. There might be the STOA committee might be doing a study, and they should have watched this actually. It will be perfect. So thanks to the speakers, really great. Two areas of questions. You mentioned the infrastructure for ammonium and LNG. How different is the infrastructure in ports? I'm a bit reminded of the electric infrastructure for cars at the moment. So if you need to spread this at the moment, even I guess even in smaller Mediterranean ports, you always can bring a petrol truck to the port and supply supply diesel. But what about if you need to expand now the infrastructure to any smaller ports in the Mediterranean? What are the barriers there? Of course, the same applies then for if you need to electrify or provide electrification infrastructure for the vessels. And then another question would be ammonium versus hydrogen. Is there an ongoing political battle for financial and political support? Is it already happening, or are they going in the same direction? Thank you.
Anyone want to respond? Of our speakers who want to respond to either of Bjorn's questions about the smaller ports? I see we've got a hand up. So.
Oh yeah, that's a new question.
Oh, sorry. Okay, let's go. Sorry, let's go for answers first then. From any of our, Michael.
We have some experience, of course, with LNG. It has taken LNG roughly 20 years to become, let's say, 2-3% of the global fuel bill, which it is today. It is now accelerating because we now see that certain kind of large industry players that consume a lot of volume are putting their weight behind them. SEMA, CGM is one of them. You see LNG carriers more in favor. You see certain amount of tanker vessels being built with LNG, car carriers, for example, companies that are exposed to a lot of close to a lot of public image. Cruise vessels is another one. This has taken roughly 20 years. it is much more than only making sure the fuel can be bunkered in when it comes to ammonia, when it comes to hydrogen. A lot of the policy still needs, so safety regulations still need to be developed to use it as a fuel. When LNG started, LNG was already transported on board of vessels. It was only, are we also going to use it as fuel? So that step was smaller than it is today. At the same time, the pressure today is larger. I mean, it's clear that something needs to happen now. So I think this is something that we need to be realistic on. How quickly will this infrastructure develop? It is not that it's happening within a couple of years. It takes years to build up because we are speaking about billions of investments. So this is clearly something that we all need to be aware of. We can have a hotspot here, we can have a hotspot there, but shipping needs to have on both sides of the, let's say, of the sea or ocean, bunkering infrastructure.
Great, thanks for that, Michael. Maybe a question from the room and then one from online, if it's, or should we?
I was wondering if the other speaker.
Oh, sorry, yeah, sorry. If there's any other speaker who wants to come in on Björn's point. No, in that case, maybe we can take one from the room and then we can go back to the online if it's okay.
Yeah, so I've got a question for the companies that are involved in ammonia. Where is the research and the eco-tox studies on the impact of ship level spills from ammonia? Like I understand that, you know, there's a certain amount of, oh, well, we transport it as a chemical commodity, so therefore we know how to handle it. But I am concerned that using something as a fuel is very different to transporting something as a cargo. And so sorry, I should have said I'm Lucy Gilling from Caesar Risk. And so I'm really searching for the thorough risk assessment of what, you know, 3,500 tons of ammonia accidentally leaking from a ship would do to marine environments. Where is that information? Because, you know, we should, even though we have urgency, we should still always be applying the precautionary principle before deploying new technologies.
Great question. And anyone who says precautionary principle has a lot of friends here at Client. Any thoughts on this point about the risk assessment? It may be that that's a major gap that needs filling that we were talking about.
So sorry, I didn't get the first part of the question. I had some trouble.
Sorry, I think because
hearing.
the microphone is near me and not near the speaker.
Yeah.
If I could repeat and you'll tell me if I'm getting it wrong, Lucy. That it's about the risk assessment of what happens if there are spills when ammonia is being used as a fuel.
Yeah. Yeah, it's an essential part of the projects that we have, and also there's a research gap because, for example, in Norway the climate is other than in the Mediterranean, and the hydroscopic weather can be more dangerous than a dry climate, etc. So there's a lack. Definitely. So it's an ongoing research to develop better methods for risk mitigation. And yeah, I totally agree. And it's also, of course, yeah.
No, sorry, I didn't mean to cut you off.
No, that's okay. Thank you.
No, I think I was going to say it's a very good one to keep in mind, because in a moment we'll get to what we need to do in order to make all of this decarbonization happen, and maybe that's a key point for us. Maybe we can just take the one last question and then move on to the workshop bit, if that's okay, and I will hand the floor over to Daniel from Europesh.
Yes, hello and everyone, and thank you for the very interesting presentations. I just had a very basic question. Do you think the technologies that you were showing during today's event, do you think they are applicable to small-scale fishermen in the European Union? Because basically around 75% of our vessels in the European Union, they are less than 12 meters length. So do you think that the majority of most of the technology advancements that you were showing can be applicable to those vessels? And I just heard about the risks on the environment, but are you checking also the safety risks of these technologies? For instance, installing liquefied gas technologies inside of a vessel. I think that, well, with bad weather conditions could pose some challenges. So that would be the question. Thank you.
Anyone on this point of small scale?
In our case, at least, the problem with going smaller to 12-meter unit high sail is the cost. When you go to large installations and you're thinking about a tanker, maybe you're putting 3 or 4 sails, then the control is the same. Either you put 3, 4, or just 1 sail. So the problem is cost when you go down to the fishing segment and you go even lower to the long liner we installed. Right now, we're offering the 12-meter unit for vessels such as the long liner we showed. If you're going down, then the problem maybe might be the payback. It's not that you cannot do it, it's that maybe payback would be a little bit higher.
Yeah, maybe if I may make a comment, I think the building blocks of the small vessel compared to the big vessel more or less is still the same. It's still a propeller that needs to drive the vessel. It still needs a shaft line. It still needs an engine, and it needs a fuel. However, looking at the future fuels, I fully agree. Pressurized storage tanks, LNG tanks, hydrogen, ammonia. It's extremely difficult to put that already in an existing fishing vessel, which is big, 70, 80, 90 meters. If that needs to find a place at a 12-meter fishing vessel, we will be speaking about extremely limited range. So I see the applicability of that very limited. If battery technology is advancing further, it might find its way into the very small fishing vessel operating in coastal areas or in aquaculture vessels. However, I think that certainly those very small fishing vessels need to rely on low/zero carbon fuels in a liquid form, biodiesel, potentially methanol when that becomes available. So that would be my 2 cents on this specific subsegment.
Thank you for that, Michael. I know a lot of the vessels that George was showing us were fairly small scale. They weren't fishing vessels, but perhaps that's a technology that...
I can add to that point as well. The smallest vessel we done was the hydrophil, which was I think around 16 meters, and then we're scaling up since then. And I totally agree with the guys. It comes down to the limitation of getting the storage on board and getting enough autonomy on board the vessel for the amount of cost you're adding to that vessel. It is very difficult on them smaller vessels.
So a definite challenge for us. We've got about a half an hour now for a workshop. One thing I want to point out to the people in the room is that we have sweet things on the table over there. So if that gets the creative juices flowing, please do not hesitate to get up and grab something to have. And for you online, don't hesitate to eat sweet things as well. We're a small enough group that I think that we can do all of this together. We've got basically a goal for ourselves, which is let's try to identify 3 factors that would help us realize the decarbonization of the fishing fleet. I've got a few questions that can help inspire that. If we get more than 3 factors, I think that that's fine as well, don't worry, but I'm hoping that we get at least 3. We've got a flip chart over here so I can write some notes on it as we discuss. If anyone wants to start, I'm happy to call on you already. If not, if you feel like the dessert is not quite enough to get everything going, I've also got some questions to ask you. Yes.
Yes, I'm Jacob from Transport and Environment, so we do mostly cargo and passenger shipping decarbonisation. So we don't really do much on fishing, partly because it's a different kind of kettle of fish, and partly because there's just no political will to work on it. So my point was really, I think the big thing lacking is the regulatory framework, because it's great to see obviously companies innovating and kind of bringing out new things, but that's never going to get into the market, especially kind of to all of the vessels it needs to, if there's no reason for people to invest in it, especially fishing vessels, who aren't going to spend more money to be green because it just doesn't matter. And then their clients and consumers don't care. So I think that's the big thing for me. And obviously, so on that, the Energy Taxation Directive is partly useful. It might increase the price just slightly for fossil fuels, but it's not going to do the fuel switch we need. So for me, that's the really big thing. I'd be really keen to hear what everyone else thinks about how to kind of tackle that obstacle.
Thank you for that. So I hope that our colleagues...
So I was asking, so people online, they cannot hear us really well.
Sorry, yeah, I was thinking that. I might just quickly amplify what Jacob said, which was that about the regulatory framework, and that we need to, it would be good to have a discussion about the regulatory framework because we can have all of the wonderful solutions that we want, but until the regulatory framework adjusts in such a way to push operators and those in the industry towards these solutions, we're not going to get there. And that the Energy Taxation Directive is not enough on its own. Yeah, we'll try to walk around with this microphone a little bit, if that's okay. Although it doesn't travel too far. Maybe speakers can just come up actually as well. Anyone else have any thoughts? I put the regulatory framework up there. So any thoughts on regulatory framework, I think would be very, very welcome. It was pretty clear to me, I think, as I was hearing the speakers, that the incentive structure is not in place for this. Even if the technologies are getting there. Oh, sorry. Yeah, Daniel, go for it.
Yes, thank you. Now that you're addressing the regulatory framework, I would like to talk about the space on board, because actually some of the speakers said that the space on board is limited and we would need much more space. Actually, somebody said twice as large, the vessel. So the problem that we see in the fishing industry that we do not see in the maritime world is that we have capacity ceilings in the European Union. So once you reach the limit in terms of global figures, in terms of GTs and kilowatts, then you cannot go over those. So if we want to include this technology inside of the vessels, most of the time require more space on board. And even though the goal is to operate more efficiently, then you see that you find some sort of limitations in legislation. So I don't know if this is also happening in other countries like in Norway or around the world, but this is something that is quite a limit for us to include these new technologies. And we also see similar limitations when it comes to funding, not only concerning the size of the vessel, but when we see that for vessels over 24 meters, the European funding is really low, it's not existent actually when it comes to replacement of the engine or improvement of the working conditions and spaces on board. So for us, obviously the intention is not to make a fishing vessel that is with higher fishing capacity, but a fishing vessel that is performing better. But here we really need to reach a balance. Perhaps I don't have like a magic wand with a perfect solution, but I think this is something that we really need to discuss, because if we really need more space on board and the technology is not applicable for small scale vessels, yes, new biofuels may come to the market. I don't know at which price. That is something that we also need to discuss, like availability on the market, supply, again, fishing ports, which ones will have to take these capabilities. But again, I think the space on board should be a serious discussion on the table at European level. Thank you.
Thank you for that, Daniel. I know those online don't see what I'm writing on the very basic technology of the flip chart, but I put a separate category for funding, which is also something that I think that we need to talk about, which is basically if we are to make recommendations to decision makers about where to channel funding, what should we tell them?
Yes, I think we need to make a distinction of what is included in the funding, for example, the EMFF, because indeed there is a limitation for 24 meters, but the EMFF has not been designed as a very visionary fund. I mean, they don't tackle any of the alternative fuels and technology we are talking about. And there are other funds available where this technology can be tackled. The only energy efficiency that EMFF is foreseeing is energy efficient of the current systems which are run with fuel. So I think it's a completely new world we are looking at, which can be covered by the Just Transition Fund. I mean, there are experts from the Commission here that might know better. I know that there is a new program called Repower the EU, where you can refocus funds so that you can move towards decarbonization. So we would have to look in those mechanisms, but I'm sure that we can include moving away from fossil fuels and working on alternative energies and alternative systems, which are completely different from what is foreseen in the MFF, which is a very old-fashioned fund.
Yeah.
So I mean, this is slightly a question as well for Christina, but as a suggestion in terms of funds, I think, Christina, you said that the wind technology can work on smaller vessels, but that I think you said it had lower buyback or something, which I assume means it's a lower return on investment. Is that what you mean? So it's a higher cost, maybe?
Yeah.
So, I mean, yeah.
So the thing is that when you go to the overall cost, and then you have to put the price up, obviously, on top, there's not that much difference in certain parts of the technology when you upscale it. So we're offering the smallest units. It's a 12 meter, which was installed in the 35 meter long liner, but the tallest one, it's around 30 meters. And in terms of cost, I mean, obviously it differs, but when you scale up, their costs that are the same. So in the end, you have higher prices for the fuel savings you can get, because if you're going to cruise vessels which are going at high speeds, then the power is obviously going to the power of 3, and then you obviously have high fuel consumptions. And the way you get back your money, it's because you're not burning too much fuel. Then obviously there's another level, which is that fishing vessels, and it's something that was mentioned before, are not going to the market and getting the best price for those fuels. So who is also going to assure that the fishing fleet is going to get these new alternative fuels at the price that is also in the shipping segment. And today, one of the problems that our customer had, Orpago, which is the fishing ship owner in Spain, was that they were operating in Panama and Peru. So they were paying for the heavy, not heavy fuel oil, but marine gas oil. At that time, it was before 2020, in fact, double the price of what the market was getting, because of how big their fleet was with respect to others. So they were small, pretty small. And then obviously because of the area. So obviously the payback is not only because of does not only depend on the price, but also how much are they paying for the fuel. So this is also another problem for them. They can get good paybacks too, but it really depends obviously on how much they're paying for the fuel.
Mm-hmm. So is there a potential then in terms of, I mean, as Daniel mentioned, and Flaminia said, the EMFF is not really designed for driving and incentivizing innovation here, but with, new funds, is there potential to, I guess, support and incentivize getting this wind power onto smaller vessels and like actual fleet, at a fleet scale, I guess, to also help to improve the buyback or payback of it?
Sure, yeah.
Maybe another point also is that it's true that the ETD is not going to be sufficient. If we introduce that taxation, we're going to have money flowing in, and this money can be reinvested in decarbonization.
Yeah, let's get you near the microphone this time.
Yeah, sorry, just so on the same theme of kind of like, sorry, hi. No, on the same theme as kind of innovation and technologies for smaller boats or the smaller vessels. Just a lot of the speakers didn't speak a lot about electrification. I understand obviously for CMB and for Fortuna, obviously the focus is on the bigger vessels. Hence why as you say, fishing is going to be kind of a technology taker. But yeah, maybe the colleague, I mean, obviously looking at Norway, there's the Yara Birkeland, so we've got this really big battery powered vessel. So I just wondered if, especially the colleague from Sintef or others had a kind of, an opinion on electrification for fishing.
Yeah, I mean, that's for the smaller fishing vessels. There are several projects going on, and the first electrified vessels, partly electrified, was in 2016. So it's really a development there, especially for the small fishing vessels. And I can also mention in relation to the CO2 tax, for example, that in Norway, fishing vessels has not been forced to pay the CO2 tax, but in 2021 they have to pay the tax. And the result from that is that they bunker not in Norway anymore, they bunker outside Norway, and then they don't have to pay the tax. And then There is a compensation for the fishing vessels in Norway. So if based on the catch, so if they have bunkered abroad, they do not have to pay their tax and they get a compensation. But that is going to change now. But it just shows the complexity and that you have to have not look country specific. You have to have a view of all Europe, so to say. So you don't move these CO2 emissions from one country to another. And you mentioned this, that it's also a suggestion in Norway that the CO2 tax should go into a CO2 fund that will support technology development and installations. And the 3 LNG fuel vessels that are coming in Norway, or one is already in operation, they are mainly a result from the NOx fund in Norway, that they had to pay a tax for nitrogen oxides, but it went into a fund and then they could apply for funding from that. So,
Thanks for that, Cecilia. We've got, I think Christina wants to come in. Go for it.
Yeah, I think someone there in the room said that it would be nice to have like a fund coming from, like, similar to ETS, that's they want to launch in the European Union. So being able to have a bunch of money to reinvest it into funding sustainable solutions. But at least what we know from being beside this fishing ship owner, for instance, the longliner where we installed our technology received funding only for reconversion. So they were not able to buy a new build. So the problem is that they enlarged the ship. So hydrodynamically speaking, it was not very efficient. But if you're going to new builds, then obviously, for instance, by installing our technology, which is one of the cases, even if you think about other alternative fuels, then you're not putting this overall cost of maybe reinforcement, stability, and so on. So I think that there's a problem between how are you financing just for reconversions, which obviously you have to reconvert the existing fleet, but maybe sometimes we're pushing too hard for these reconversions, and maybe that would make much more sense to make this new build much more efficient. That's just an opinion. I'm not an expert on EU funding for fishing fleets, but that's what the market has told me. So
I think that's a good point, at least on conversion, that we see that also in other shipping segments. We clearly also see that in other shipping segments that when it comes to there is a big installed fleet out there, and that has a long lifetime of operating, 25, 30, 35 years. So the vessels that have been built a couple of years ago, they need to be helped and incentivized to do something about their emissions. It's not only about new builds that is going to, that's the most easy way to implement all the new technology, but the existing fleet also needs to be brought along. So that they need technologies that are able to be retrofitted on board of these existing vessels. There was also a question, I believe, from the gentleman from Europesh on the space on board. If needed, I have a slide that tells about the space needed for the various fuels.
Yeah, we might as well put it up. Our colleague is just trying to stop the television from being shut off, but I know which one it is, I think.
Emergency.
Yeah.
Oh my God. That's the green one.
Yeah, that's one.
I think you've got this, it's this button in the middle.
20.
Sorry for our online friends. We had a Mission Impossible scenario, except instead of the bomb going off, we were just going to not see you. Sorry, Michael, go ahead.
I mean, if you just bring up the presentation again, then I can easily show that. Yeah, this is the one.
Oh, great. Let me just share the screen. This one there.
Yeah, we see it.
It's good enough.
Good enough. So here on this, We just do like this.
So yeah.
Yeah. So here on this slide, we see the energy density. So how much space does fuel require on board when we speak about the same energy content? On the left, we have 1 cubic meter of fuel oil. So that's what we all know. If we would use the same energy in terms of LNG, liquefied natural gas, so that is liquefied, then it's 1.75 cubic meter, and that's only the space needed for the chemical itself. You see there is a storage tank below. So LNG requires storage in minus 150 degrees below zero, so that requires a special tank. Methanol, we go to 2.63 cubic meters for the same energy content. With methanol, we can store at room temperature in free-form tanks. But when we speak about ammonia or hydrogen, we speak about 3 cubic meters or 4.6. So there is a lot more space needed for the same energy, the same endurance for the ship. This is only the space needed on board. This is not speaking about safety systems, etc. This is only about the space. So in terms of small vessels, compact vessels, space on board will be probably a big driver of what fuel these vessels can work with, or they need to be able to sacrifice a lot of endurance. But I mean, the fish is still out there in the ocean, and you still need to go to the fishing grounds and come back. So that's certainly something to take into account.
Thanks for that, and that's a very helpful slide because I think it shows quite visually the problem. Yeah,
Maybe another point for our board is that for fishing, I mean, it was part of the discussion we had previous the start of the workshop, but I think it's quite useful to realize that it's not going to be standard, so that we will have to be very flexible and combine different technologies according to the needs of each fishing fleet and each fishing segment in different seas. So it's going to be like a bit of a puzzle that you create your own puzzle that works for you and for your needs. And of course that will require it will require patience, it will require money, but I mean, the money problem will be all the way through. But there is also something exciting that we need to be extremely innovative. And so, yeah, we can see it that way.
Yeah, Vera, please come up to the. It's right here. Yeah.
Yeah. So just perhaps a bit of a side debate, but it's clear that it's going to take time, right? Because we need to think of retrofitting, we need to think of fleet renewal, we need to think of infrastructure rollout. As Michael was saying, it's going to take years, if not decades, to really massify this transition that is urgent, but that we do have a time limitation. In the meantime, shouldn't we also be thinking about different ways of fishing and other ways that we could perhaps not fully decarbonize, but at least reduce the carbon footprint of fishing? And this would then go more towards fisheries management, fishing decisions by fishing companies about things like fishing less deep, less far from shore, with less bottom contact. So having different ways of fishing that also reduce carbon emissions and, by the way, impact on carbon-rich habitats, but to initiate the process of decarbonization not only by changing one for one, I have an engine that requires 1 cubic meter of fuel. How do I change that one for an engine that requires something else? But really think of the way that we fish. And that would then also feed into all the discussions on fleet renewal. What kind of new fleet do we need that both incorporates the decarbonization of the vessels themselves and of the fishing operations and of the fishing activities at sea?
Yes, thanks for that. I think this gets to, sorry, I'll come closer to the microphone. I think this gets to something that was kind of playing in my mind as we were talking about renewal or new vessels versus retrofitting vessels, which is the fact that we have a limited resource that we can go after. So obviously, and we're at capacity in order to actually go after that resource. So how, yeah, overcapacity is, Becca's rightly saying to me, and something that Client Earth works on very heavily. So this is about how do we actually transform the fleet that we have into one that is more efficient at getting just at the level of resource that it's allowed or below that level as opposed to going over it. I'm wondering around if unless anyone wants to jump in. I was just thinking about, yeah.
Well, I think you make really good points about like what is the system and what does the future look like. And perhaps it's different types of vessels, different types of methods. And, you know, with that in mind, I just like, and it's wonderful presentation from Bound for Blue, but, you know, don't think that, you know, the maximum we can get from wind is 15 or 30%. There are new builds, you know, hybrid vessels that could be completely zero emission, where there could be a much more significant proportion of propulsion coming directly from the wind. So, you know, I think it is, you know, if you're in this time when you're like imagining the future, make sure that we're really imagining big with all the different options on the table.
Yeah, absolutely. And I mean, the one thing that this is the thing that came into my mind, I think, really from Cecilia's presentation, which is that if I were working in the industry, I wouldn't feel the fire behind me, if I can use a combustion metaphor, the fire under me to actually convert, because maybe we can get, and I hope that we can, it sounds like we can get a lot more from wind, for example, but what is my incentive structure when I'm not required to account for the greenhouse gas emissions from my fishing vessel, when no one's even counting them at this point, and I can keep running my business model as it is. We were at an event last night, some of us, where someone was saying there is no business as usual, it's all business unusual, but these are, with this incentive structure in place, business as usual seems to predominate. I wonder if anyone has any thoughts about getting back to the regulatory framework. So the energy taxing fishing fuel would obviously be one fix here, but not maybe the whole fix. Any other thoughts about the regulatory framework? Or thoughts about the energy taxation? Oh yeah.
I'd like to answer the woman in the room. In our case, we're talking about 5 to 15% with the ship, because sometimes when they are operating, this longliner is doing some circles. In Spanish, it's called viradas. So they're not using the wind all the time, and sometimes they're going against the wind, so you're not able to use it. But in those areas, specifically, if you want to go fishing in a specific area and there's wind available, you can use it. I mean, it really depends if you want to use on top also the main engine, or you just want to use the wind. So it really depends on the operation of the ship owner. And then regarding the regulations, I would say that in this case, for this customer, with the results we've achieved, we've calculated a payback of around 2.5 years if they've paid for the technology. So that's very good in terms of sustainability speaking, not only because of the fuel savings, but also because of the economical impact. So I cannot think about putting more regulations on top when the technology is available for them and it's offering such amazing results in terms of payback. So I would say that obviously regulations will push, but if the technology is available and it's offering good numbers, then I mean, it really depends.
In our last few minutes, and the little space that I've intentionally left at the bottom of the flip chart that I want to fill, I was just thinking about research. Where are the gaps that we have in terms of, and also if other people want to come in on the regulatory framework, but Lucy made a very good point, I think, about safety studies, which I would put on the flip chart if.
And eco-talks.
And eco-talks, sorry.
Sorry, Adam, I just wanted to say something about the regulatory framework, because Michael, in his presentation, he said something and I never thought about that before. Perhaps I'm just really stupid. It's the fact that fishing is going to follow the trends in the maritime sector. Yeah. Because it's a small sector compared to the marine sector, shipping industry, etc. So it's going to follow everything which is going to be, you know, implemented in terms of infrastructure, new energy technologies, etc., etc. And so I think when it comes to the regulatory framework, everything which would be applicable to the shipping sector, even if it's not applicable right now to the fisheries sector, is going to have an impact. So yeah, notably the ETS at the EU level. And IMO.
Yeah. But IMO currently has no efficiency regulation, so it's exempt from any efficiency standards.
Fishing is also exempted from ETS.
Yeah.
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 Yeah, I feel like the regulatory framework issue, or maybe the elephant in the room, to put it that way, is that fishing needs to be taken into account in the regulatory framework. But I also take that Michael's point, and I think that Jacob summed it up as saying that fisheries is a technology taker. I hope that I'm using the phrase right, but that's something that I think we haven't thought about very much, and actually is a really good point. We'll be a technology taker, but we need to make sure that it's in that framework as well. I think we've got Daniel and then Lucy, if that's okay. Daniel, go for it.
Yes, hi again. I just wanted to comment on the on how to force the fishing industry to transition, and I think the fuel price is going to be a main driver. The price that our fishing vessels are paying nowadays is well, it was double, and now I think it's going to get to triple the price, and to the point that some fishing vessels are asking themselves, fishing vessel owners, like if they should continue fishing, because obviously the numbers, they don't add up, and the situation is really difficult, and it's lasting longer than expected. The thing is that introducing at this point taxation or taxes in fuel price, or I don't think that would force transition to anyone. That would just cause like more people or more vessels stopping operating until the situation is getting better. And I think that this option should not be considered until the logistics and the technology is ready. Otherwise, you're just penalizing the fishing industry. And as said by our colleague from Norway, if you just do this in the European Union and not everywhere else in the world, then large fishing vessels, they will get the fuel from a different country or international waters at international price. But I don't think it's going to be a driver for change. I understand that for the marine shipping industry is easier to get into this transition, but I think any solution should be done at the international level, and I think WTO is currently discussing this. And well, we see some changes in the latest draft, but let's see where we're going. But to be honest, I don't think this is the right moment to talk about the taxation when it comes to the fishing sector. But I understand that you may have a different opinion. But really, until the technology and the logistics are ready, I don't think it is the right moment. But well, thank you.
I might let Beck cut in, and I'm biased on this because you know that we've got a different opinion, so I'm going to abuse my position as chair.
Well, I just also have a question back then, Daniel. When is the right time, and what would incentivize the fishing industry to become both to use less fuel and or to transition more rapidly? Because I think, Flaminia's point before, and I mean this, I'm going to use an example of a different area in fishing, but minimizing bycatch and improving selectivity of fishing. There's been a number of incentives, and they have not been taken up, particularly over the last few years, in terms of implementing the landing obligation, which is a different part of fisheries policy, but it still stands. It has still been very, very poor, and the industry has not really taken it up. So, okay, fine. If you think that it's not the right time and it's not a good enough incentive to tax, then what do you think would work?
Well, I'm happy we are we're having this discussion.
Because I think it's useful to hear from you, especially.
Yeah. No, and thank you for the question. To be honest, if I may take the floor. Yes. Is it
go
right?
for it, and then we've got someone else in the room who also have a comment, and then
okay.
Yeah, go for it.
Thank you for that. Having seen all the presentations provided today, I think that most of the projects that we've seen is just projects and experimental exploration on a way forward. And this is great technology, and I think that this requires a lot of investment. So I'm really proud of all these companies that are doing every effort to make the transition happen. We don't yet have the one technology that is going to work for everyone. And I think this is like same with mobile phones and with the chargers. We don't have just one. We have a different prototypes and models in the market. So I think first we need to have the technology, and then it has to be operational. So it has to be ready at commercial level. Second, again, we need to have a good legislative framework. We need to recognize that there is a problem with the space on board in the fishing industry that is not happening in other industries. And then finally, well, I see that a mix with fisheries management, which I think is also like a necessary discussion. I understand that you want to reduce as much as possible fishing trips, and I think that is also the priority for any ship owner. That you just want to burn less fuel as possible. But if you are chasing the fish that is moving in international waters or across nations, etc., then obviously you need large vessels with that are capable of large fishing trips, and within these vessels you are going to try to install all these technologies that you were referring to, and I think that these ones this will be the first in installing these technologies and creating the progress in the fishing industry. And then I think there's many projects, and even with the funding from the European Union of our vessels that are investing in technology, in better selectivity, in less contact with the bottom of the seabed, because actually if you touch less the seabed, you are burning less fuel. So I think it's a win-win for everyone. But then I think it's a different approach, investing money to try to comply with the landing obligation, which I think is a different approach. But I can guarantee that I actually have a full list of projects in the European Union with organizations and companies collaborating with scientific institutes and technology providers in order to try to minimize the impact. So I think all this is needed, and I don't know how many years we will need to put this taxation operational, but I don't think it's the right moment, and especially with the fuel prices and the problems that we have with neighboring countries. I would say at least a decade, because this is what I heard from industry, from providers today, that this is going to take years, if not decades. Thank you.
I might let one more person in the room who wanted to come in on this point. Please do, and maybe tell us who you are. Sorry.
No, yeah, my name is Antonio from EEB, European Environmental Bureau. I actually not adding anything new. We already mostly said this, but I really think my opinion is that prices have been so far not high enough. So the point is that the prices are not high now. They were too low before, and unfortunately, this has spoiled our industrial sectors. And now we are comparing different technologies, and it is correct to compare them, but we don't have the right price signals to compare them. So we have new technologies that we are going to compare with an old technology that is mainstream, that is based on fossil fuels, but prices of fossil fuel prices don't really take account of every cost. So we are not really comparing correctly, and we are making mistakes by this. So I really think that mostly because we don't have the time to wait a better moment, we have to start and to find solutions right now by setting the right prices to different fuels. Then paybacks could be very different if you have the right prices. If you don't have the right prices, if you are cheated on prices, then you will not find the right solution for sure. Okay.
Thank you. Thank you. I wanted to give the word to Lucy, who I think had a question. No, it's okay. Then maybe I think it's Griffin, because I know that I've seen you in videos before, but we've never met in real life.
Cool. So I don't work on fishing much anymore, but I work on electric vehicles, which is maybe the success story of zero carbon these days. And I think it's interesting to draw the parallels because, yeah, it's a little bit further ahead in the transition. But when we go back 10 years ago, when we were first setting CO2 standards for cars, it didn't exist. So right now, in order for a fleet, VW or whoever to produce vehicles, the maximum fleet average needs to be 95 grams per ton. There's no such per kilometer. There's no such thing as a vehicle that does this. They invented a standard that no vehicle could meet. So you had to add electric vehicles to bring down the average because a petrol or a diesel cannot run at 95. So the point is setting policy with a bit of a time lag into the future, and you set the direction. So I think I agree that right now it's more experiments, seeing what technologies are available, and we might not change the fleet tomorrow. But in fishing, we're just at such an early stage where it's not even clear the direction of travel. And it at least needs to start being included in some regulations. And just one more thing maybe for the board, but we're focused a lot on EU policy, and there might be some interesting things happening at the port level. So my colleague Jacob mentioned before the meeting that in California, there's things like, it's equivalent of like low traffic neighborhoods and stuff where the port is a low carbon area. Well, not just low carbon, but shipping pollution as well. So I wonder if that's kind of like a policy innovation that could take place in an area. I wonder where in Europe could lead on that.
Thanks so much for that. And it is 2 o'clock. I'm supposed to say something about next steps. What I want to say first and foremost is that I think that the decarbonization of the fisheries sector is inevitable, but the question is how long is it going to take and where are we going to start from? And I'd like to think that we've made a bit of a start here in thinking through some of the ideas. And the next steps for us, I think, are to take the ideas from today and formulate them into some policy asks. And I think we'll be getting back in touch with some of you in order to refine those. But I found this really interesting. Personally, it really took me out of my comfort zone in terms of I'm a law person. So thinking about the different technologies I find really, really exciting. It was really nice to be to a pretty successful hybrid event, I think, and we have colleagues to thank for that. Particularly, I just want to say to you, Elisabeth, Beck, and Flaminia, who were involved in organizing this, and to all of the speakers, thank you so much, and to everyone. There's still some dessert here in the room, and maybe some sandwiches next door, so you don't have to leave before you've satisfied your sweet tooth. But thank you very much for being here today.
Thank you, Adam.